This is Chapter 4, Lecture number 2. We're on page 53 in the notes, and we're going to start by discussing atomic number. If elements are a collection of protons, neutrons, and electrons, then what makes one element different from another? The difference is based on the number of protons in the nucleus. All atoms of hydrogen have one proton, and therefore its atomic number is 1. All atoms of nitrogen have 7 protons and an atomic number of 7. So the difference between nitrogen and hydrogen is simply the number of protons. All atoms of the same element will have the same number of protons in the nucleus. And since atoms are neutral, the number of electrons will also equal the number of protons. So carbon atomic number 6 will have 6 protons and 6 electrons. Turn to page 54. So if we have an atomic number of 82, we will have 82 protons and we will have 82 electrons. Atomic number 82 is lead. Use your periodic table for this next part. If we have 8 protons, we will have 8 electrons. Our atomic number is 8, and if we look up atomic number 8, it is oxygen. If we have 30 electrons, we will have 30 protons. Our atomic number will be 30, and we look up atomic number 30, and it is zinc. After atomic number, we have what's called a mass number. The mass number is simply the total amount of neutrons and protons in the nucleus. The electrons are not considered because their mass is almost 0. So here we have one way of writing gold. We could also say gold dash 197. Each of these just represents a way of writing gold, but it allows us to figure out how many protons, neutrons, and electrons are in that specific element. So protons is the atomic number, which is 79. The number of neutrons is simply the difference between the two numbers. So there are 118 neutrons. The electrons equal the number of protons. The mass number will always be the top number, which is called a superscript in the symbol. What is kind of a conceptual concept is what an isotope is. Isotopes are atoms that have the same number of protons, but a different number of neutrons. Isotopes are chemically similar because they have the same number of protons and electrons, and these are the subatomic particles that determine chemical behavior. So there are 3 isotopes of hydrogen. The first isotope is hydrogen 1. The second isotope is hydrogen 2. And the third isotope is hydrogen 3. Notice they each have the same atomic number, 1, but they each have a different atomic mass. So where hydrogen 3 has 2 neutrons, by subtracting the numbers, hydrogen 1 has no neutrons because 1 minus 1 is 0. So here we have a chart. We're filling in an up-down direction. So if I have 16 protons, then my atomic number is 16. The difference between the mass number and the number of protons is the number of neutrons, which just happens to be 16. The number of electrons is equal to the number of protons. And then the symbol, we have to look up atomic number 16, and it is sulfur, and then dash and the mass number, 32. If I have 20 electrons, I have 20 protons, and my atomic number is 20. The mass number is the sum of the protons and neutrons, which is 44. I look up atomic number 20, and it's calcium, dash 44. So pause the video and go ahead and do the last three. And here is our completed chart. Turn to page 57. Atomic masses have been determined very accurately with a device called a mass spectrometer. So they know a fluorine atom has this mass, but notice how small it is, 10 to the minus 23. Here is an arsenic atom, 10 to the minus 22. So the arsenic atom is larger than the fluorine atom. Instead of always writing out these numbers, instead what we do is we do a relative mass by comparing one to another, but we need a standard. The reference isotope is carbon-12. So carbon with 6 protons and 6 neutrons. It is assigned exactly a mass of 12 AMUs, atomic mass units. Since carbon-12 has 6 protons and 6 neutrons, we should expect that all atoms have a whole number for its atomic mass compared to the carbon-12. But if we look up chlorine's atomic mass in the periodic table, it's 35.453 AMUs. The reason the mass in the periodic table is not a whole number is because it is an average of all of the isotopes and their percent abundances. Chlorine is made up of 2 isotopes, chlorine-35 and chlorine-37. Chlorine-35 is 75.78% of all the chlorine out there. Chlorine-37 is 24.22%. The average mass that's calculated is not just adding up and dividing by 2. We have a different equation. Average atomic mass is equal to the mass of that particular isotope. In this case, they're telling us chlorine-35 has a mass of 34.969 times its abundance as a decimal. So 0.7578 plus the mass of the next isotope, rounded in this case to thousandths place, times its abundance written as a decimal. If we had 5 isotopes, we would have to do this 5 times. But since we only have 2 isotopes, we only have to do it twice. And if you now do this math on a calculator, you will get 35.453 AMUs. A generic equation would be average atomic mass equals mass times relative abundance plus mass times relative abundance plus ... for however many isotopes that you have. We're going to do some problems in class, and that will be it for lecture 2.